let's start with the integral of cosecant of x dx. So, if you're going to do this the normal way, wherein you will put this in the simpler form, which would be 1 over sine of x dx, and you will do u substitution. Let u here be sine of x. Du right here would be the derivative of sine of x, which is cosine of x dx, and dx right here would be equal to du over cosine of x. And when we substitute this, we would have 1 over u multiplied by dx, which would be du over cosine of x. You can see here that there is a cosine of x here, which cannot be cancelled by any other means, so this cannot be the solution. So just like with the second trigonometric for integral of that, we will have to use a trick, which will be the integral of cosecant of x, and let's multiply this by a value of 1, which can be this cosecant of x minus cotangent of x over cosecant of x minus cotangent of x. This term right here is equal to 1 of dx. And so, when we will multiply this, we would have cosecant squared of x minus cosecant of x, cotangent of x, over cosecant of x minus cotangent of x of dx. And now, we can use u substitution here once again. Let u here be cosecant of x minus cotangent of x. And the derivative of cosecant of x would be equal to negative cosecant of x, cotangent of x. And the derivative of cotangent of x would be equal to negative cosecant squared of x. And multiply this by dx. And so, what we have here would be equal to negative cosecant of x, cotangent of x, and this would be positive cosecant squared of x of dx. And so, getting the dx right here, we will have du over negative cosecant x, cotangent of x, plus cosecant squared of x. And so, by substituting this, we would have the integral of this value over this one corresponds to the value of u. And so we will put u here and multiply this by value of dx, which would be du over negative cosecant x, cotangent of x, plus cosecant squared of x. And so we can simplify this. Negative cosecant x and cotangent of x would cancel each other out. And cosecant squared of x would also cancel each other out. And so, what we are left here would be equal to this one. Let me just make some space. Would be equal to the integral of du over u. And so, the integral of this would be equal to the natural log of the absolute value of u plus c. And so, the final answer here would be equal to the natural log of the absolute value of u, which is this cosecant x minus cotangent of x plus the constant of integration. The integral of cosecant squared of x dx. Here's one thing you should know. The derivative of cotangent of x would be equal to negative cosecant squared of x. And so, by reverse, the integral of cosecant squared of x would be equal to cotangent of x. But since this is negative, this should be also negative. So the integral of cosecant squared of x would be equal to negative cotangent of x plus c. The integral of cosecant cube x dx. So the first thing we're going to do here is to factor out a cosecant squared of x dx. But we cannot transform this into its trigonometric identity because this shall be part of dx. But what we can do here is to use integration by parts. So let us use the di table, which under derivative would be cosecant of x, and under the integral would be cosecant squared of x. The derivative of cosecant of x would be equal to negative cosecant x cotangent of x, and the derivative of cosecant squared of x would be equal to negative cotangent of x. So this would be cosecant x negative cotangent of x. So this can be negative cosecant x cotangent of x minus the integral of negative cosecant x cotangent of x multiplied by negative cotangent of x dx. There are two negatives here, so this would cancel each other out. And since there are cotangent x and cotangent x here, this can be cotangent squared of x. And so we can now put cotangent squared of x into its trigonometric form. Remember that cotangent squared of x would be equal to cosecant squared of x minus 1. And so this would be this one. And so distribute cosecant x into the parentheses. Dx. And so we can split this integral into two parts. It would be the integral of cosecant cube of x dx. And since this is negative cosecant x and we have a negative, this can be positive integral of cosecant x dx. As you can see here, we have a cosecant cube of x dx and we have a repeat of its problem. And so you can say that this can be a loop if you can treat this carefully. So what we're going to just do here is to equate this. And so just copy this. This would be the integral of, wait, let me just rewrite this. This can be the integral of cosecant cube of x dx. This would be equal to this value right here, which would be negative cosecant x cotangent of x minus the integral of cosecant cube of x dx plus the integral of cosecant x dx. And so add add integral of cosecant cube of x dx to both sides. And so this would be equal to 0. And so what we have here is 1 plus 1 would be equal to 2. The integral of cosecant cube of x dx, which would be equal to negative cosecant x cotangent of x. And so what we're going to do here now is to simplify this integral. And the integral, I mean this. And so the integral of cosecant of x dx, as in the earlier problem, it is equal to the natural log of the absolute value of cosecant x minus cotangent of x. And don't forget to add the plus c. And so that we have this answer, let us multiply both sides by 1/2 in order to get rid of the 2 here. So multiplying this by 1/2 also, this will equal to 1. And so the final answer of the integral of cosecant cube of x dx, this would be equal to 1/2 multiplied by negative cosecant x cotangent of x plus the natural log of cosecant x minus cotangent of x plus c. I mean, you can distribute 1/2 to this too, but I will just leave this as it is. Let us continue on with the integral of cosecant to the power of x dx. Let us continue on with the integral of cosecant to the power of x of dx. And so we would factor out cosecant squared of x. And so since this is part of dx, for this we have a cosecant squared of x, and so we can transform this into its trigonometric identity. Cosecant squared of x would be equal to cotangent squared of x plus 1. And so by transforming this, we would have the integral of cotangent squared of x plus 1 multiplied by cosecant squared of x dx. And so by distributing this, we would have cotangent squared of x cosecant squared of x plus cosecant squared of x of dx. And by splitting this integral into 2 parts, this one and this one, we would have this given. And so we would focus first on this first integral. So let u here be cotangent of x. The derivative of cotangent of x would be negative cosecant squared of x of dx. So what we have here, would be equal to the integral of cotangent squared of x. It would be u squared multiplied by cosecant squared of x dx. This would be this, but since it has a negative, this would be negative du, and just copy the rest. And so we can just put the negative sign outside the integral. The integral of u squared would be equal to u cubed over 3. And the integral of cosecant squared of x, as we had answered earlier, it is equal to negative cotangent of x plus c. Thus, the final answer for this question would be equal to negative, it would be negative 1/3 multiplied by the value of u, which would be cotangent cube of x, minus cotangent of x plus the constant of integration. The integral of cosecant to the power of 5 of x dx. So, we will first factor out cosecant squared of x. And so, what we're going to do here is to integrate this by parts. By the way, just some useful information. Whenever you're dealing with an integral of secant or integral of cosecant, if the exponent there is an odd number such as 3, 5, 7, or 9, you will use integration by parts. But if the exponent there is an odd such as 2, 4, 6, 8, you will just use transformation by trigonometric identities, just like what we did earlier on the integral of cosecant to the power of 4 of x. That is more simpler, and you will soon later on see how we solved the cosecant to the power of 6 of x later on. Now that is done, under derivative, this would be cosecant cube of x, and under integral, this would be cosecant squared of x. And so, the derivative of cosecant cube of x, this would be 3 cosecant squared of x multiplied by the derivative of cosecant of x, which would be negative cosecant x cotangent of x. And the integral of cosecant squared of x would be equal to cotangent of x. And so, by multiplying all of this, you would have this expression, which is cosecant cube of x multiplied by negative cotangent of x minus the integral of 3 cosecant, let's just put 3 outside now, cosecant squared of x multiplied by negative cosecant x cotangent of x, and multiply this by negative cotangent of x. Since there are two negatives here, this will cancel each other out. And so we have cosecant x here, so this can be cosecant cube of x. And there are two cotangent of x, and so this will be cotangent squared of x of dx. And so we can transform cotangent squared of x into its trigonometric identity, which would be equal to cosecant squared of x minus 1. And so by rewriting this. And so, by distributing cosecant cube of x, we will have cosecant to the power of 5 of x minus cosecant cube of x of dx. And so, by splitting this integral into two parts, we will have this expression. Let me just make some space here real quick. And so as you can see here again, we have a cosecant raised to the power of 5 of x dx, which is the same as this. So we can just equate this by copying this problem first. And equating this by copying all of this. And so what we're going to do here first is to eliminate this. And so what we're going to do here is to add 3 integral of cosecant to the power of 5 of x dx to both sides. And so this will be equal to 0, and 3 plus 1 would be equal to 4. And so the next step here is to get the integral of cosecant cube of x dx, which we had solved earlier, and the answer of this would be 1/2 multiplied by the natural log of cosecant x minus cotangent of x subtracted by cosecant x multiplied by cotangent of x plus c. And so 3 multiplied by 1/2, this would become 3/2. And so, since we have a4 here, we must multiply all sides by 1/4. And so, 1/4 multiplied by 4 would be 1. And so, cosecant raised to the power of 5 of x of dx would be equal to 1/4 multiplied by cosecant cube, this should be negative, of x, cotangent of x, minus 3/2 of the natural log of cosecant x minus cotangent of x subtracted by cosecant of x, cotangent of x, plus the constant of integration. For the last problem, the integral of cosecant to the power of 6 of x. So, as I explained earlier, the exponent here is an even number, so this will be simpler. And so, the first thing we're going to do here is to factor out cosecant squared of x. And so, we will use the identity of cosecant squared of x would be equal to cotangent of x plus 1. But since this is in the form of cosecant raised to the power of 4x, we must rewrite this. So this can be the integral of cosecant squared of x raised to the power of 2. And so by rewriting this by this identity, we would have this expression, cotangent squared of x, this should be cotangent squared of x, plus 1 raised to the power of 2 multiplied by cosecant squared of x of dx. And so, what we're going to do here first is to expand this. So this would be cotangent raised to the power of 4 of x plus 2 cotangent of x plus 1. And so we will distribute cosecant squared of x amongst this parentheses. And we can now just split the integral at the same time. So this can be the integral of cotangent to the power of 4 of x cosecant squared of x plus the integral of 2 cotangent of x cosecant squared of x plus the integral of cosecant squared of x dx. And so we can do these two first integrals. So for these two integrals, let u here be cotangent of x. And so the derivative of cotangent of x here would be negative cosecant x, cosecant squared of x dx. And so for this first integral, this can be cotangent of x. It would be u raised to the power of 4 multiplied by cosecant squared of x dx, which would be negative du plus the integral of this second, which would be 2 cotangent of x, which is simply u, oh fuck, I fucked that up. Let's move on to the last example, the integral of cosecant to the power of 6 of x. So as I said earlier, this exponent is an even number, so this will be simpler than the even. And so what we're going to do here first is to factor out cosecant squared of x. And since this is part of dx, we will focus on this one, wherein we will be transforming this identity into this. Cosecant squared of x would be equal to cotangent squared of x plus 1. But since this is in the form of cosecant to the power of 4x, we will rewrite this as the integral of cosecant squared of x to the power of 2. And so we will rewrite this according to this identity. So we will have the integral of cotangent squared of x plus 1 raised to the power of 2 multiplied by cosecant squared of x dx. And so expanding this, we would have cotangent raised to the power of 4 of x plus 2 cotangent squared of x plus 1. And so we will distribute cosecant squared of x amongst these parentheses. So we will have cotangent to the power 4 of x multiplied by cosecant squared of x plus this value and we can split this integral apart into 3 parts, 1, 2, and 3. And so we can focus first on these two and let u here in this case be cotangent of x. And derivative of this would be equal to negative cosecant squared of x dx. And so by rewriting this or substituting, this would be the integral of cotangents to the power 4 of x. This would be equal to u to the power of 4. And cosecant squared of x dx, which is this, but since this is negative, this would be negative du plus the integral of 2 cotangent squared of x, which is u squared, multiplied by negative du once again, and copy the rest. And so we can put the negative outside. So this can be negative. And this can be simply just du. Same as this. And so the integral of u to the power of 4 would be equal to u to the power of 5th over 5. And the integral of 2u squared would be equal to 2u to the power of 3 over 3. And the integral of cosecant squared of x, this would be equal to negative cotangent of x plus c. And now as we substitute u back into its original form, we can now find our final answer. It would be negative 1 over 5th. U here in this case is cotangent raised to the power of 5 of x minus 2/3 cotangent to the power of 3 of x minus cotangent of x plus the constant of integration.